Ladies and gentlemen, welcome to this audio slides presentation. My name is Marin Bugaric, and in the next 5 minutes I will speak about our recent paper entitled Adaptive Estimation of Visual Smoke Detection Parameters based on Spatial Data and Fire Risk Index. The goal of our research is to improve the reliability of the existing systems by introducing automatic adjustment of smoke detection parameters. We do this using augmented reality and geographic information system. Augmented reality is used to calculate geographic coordinates and the real-world distances for each pixel in the input image. Geographic information system is used to modify these data into appropriate information used for the adaptive estimation of sensitivity parameters. We also propose the modification of the input image by using the calculated data to achieve a higher quality of smoke detection. We have developed a scene calibration system based on augmented reality that is used to find a link between the real world and the digital elevation model. To do this, it is necessary to find a connection between the virtual and real camera models. On this slide, we have several scene calibration results where real and virtual cameras share the same view. We can now, for each point in the scene, obtain the correct geographical coordinates and distance from the camera. Using geographical information system and calculated geographical coordinates and relative distances from the camera, we produce additional maps needed for the automatic parameters adjustment, pixel coverage map and fire risk index map. For each pixel in the input image, there is a corresponding value in pixel coverage map that represents physical dimensions of space covered by that pixel. It is calculated as the projection of the space in the real world onto the plane that is parallel to the camera image plane and equally distant from the camera as the observed point. Therefore, pixel coverage map values are expressed in squared meters.
Additionally, we use Geographic Information System to produce a fire risk index layer from static information such as terrain configuration and vegetation, and dynamic information that includes current meteorological conditions. This layer is then used to calculate fire risk index map that is similar to pixel coverage map. Every value in the map represents current fire risk index for the corresponding point in the input image.
There are 5 main improvements based on pixel coverage and fire risk index maps. The first one is the adjustment of motion detection sensitivity. It is possible to adjust a single general motion detection sensitivity parameter for the entire scene, but it is better to do this on a pixel level. The movement of the objects located at greater distances from the camera is more difficult to detect, and accordingly the motion detection should be more sensitive in that case. The next improvement is selective blurring of input images based on point distances from the camera. The input is blurred to reduce the unnecessary movement and image noise. The amount of blur is inversely proportional to the distance of the terrain from the camera. Third improvement is definition of minimal candidate region size expressed in squared meters. The next improvement is dynamics analysis based on detected region growth rate. It is possible to define upper and lower growth rate thresholds taking into account the estimated size of the detected region. We can safely eliminate the regions that grow or shrink at speed greater than 5 sigma. The last is the final verification using fire risk index. Candidate regions are additionally verified by using fire risk index map in order to produce more certain final decision. In order to evaluate proposed improvements, we modified 3 standard methods based on previously described steps. The improved methods were compared to the standard versions based on the results from 2,977 images. The results show significant improvements in the furthest detected smoke distance, correct detections, and the number of false alarms. In this slide, we can also see the improvement in the local measures. To conclude, we have proposed the improvement in the field of visual smoke detection based on adaptive adjustment of smoke detection parameters. Existing methods were improved and were less sensitive to phenomena such as clouds and cloud movements, wind, movements of rivers and sea, changes in lighting conditions during sunrise and sunset. With this we complete our presentation. Thank you for watching.